This is the Differential Equations FRQ from 2015, and this one was kind of controversial. Basically, everybody came back from the AP exam telling me, Mr. Maker, you didn't teach us how to do this type of problem. And, of course, we weren't really allowed to talk about specifics, so they kind of described basics about it. And based on what they told me, I said, well, yeah, actually, you should know how to do this problem. So if you're looking at this and you're wondering what the controversy is, here's the issue. If you notice here, this is 2x minus y. It's not 2x times y, it's not 2x divided by y. If you remember, when you separate variables to solve a differential equation, you're going to multiply or divide both sides of the equation to move things, okay? You don't want to have, for example, if you move y over here, you don't want to have y plus dy. You don't want to have an x minus a dx or that kind of thing. Everything needs to be multiplied. It needs to be something times dy, something times dx. So everybody came back to me and they said, we didn't know how to get it in a form by multiplying and dividing. We couldn't do anything. And I said, guys, based on what you're describing, this is something that would be done in a Calc 4 class, which also focuses on differential equations. And they're all like, no, it was on the AP exam. And I said, well, if that's the case, then they didn't ask you to find the particular solution. And they said, oh, yeah, they did. Well, if you notice here in part C, and we'll get to this in a few minutes, but it says, let f of x be the particular solution. If you read it real carefully, they give you a value of the function, f of 2 is equal to 3. They ask if it has a relative minimum, relative maximum, or neither at x equals 2. But if you notice there, it never says find the particular solution. It just says there is one, and we're going to look at some information about it. This problem never asked people to separate variables, never asked people to find the particular solution, and a lot of people wasted a lot of time on it. So anyway, I want to take a look at what they did want you to do on this question, and a lot of the concepts here have continued to come back in future years. So part 1 here, you'll see they ask you to do a slope field, and for the particular points, you're going to put in the point 1, 1, and you'll get the slope there, and you'll plot a little segment that has a slope of whatever that slope is. You'll put in a point 1, 2, you'll sub it in up there, plot a little point with that slope. Okay, so here's the solution for the first part if you want to try it on your own. It is 2 points. It looks like we've got a couple of slopes of 0. Actually, not a whole lot of slopes, but at least one were, slopes where x is equal to 0. Okay, so you can see those, and you can see the slopes where x is equal to 1. Okay, so 2 points there. So just if you did those, you're a point or two away from having a passing level score on this thing. Okay, let's take a look at part 2. So part 2 asks you to find the second derivative. Okay, but keep in mind, you already have the first derivative, okay? So we're really just finding the derivative of the equation they gave us, okay? However, notice there's a y variable here in the equation, all right? So because we have a y in the equation, we're going to have to use implicit differentiation here. So we're finding d squared y dx squared, okay? And we're just finding the first derivative of 2x minus y. But because of the y, we've got to use implicit, and this is way easier. If you think about the implicit differentiation multiple choice questions, this is like the easiest implicit differentiation question ever. So you're really lucky if they do give you something like this. So anyway, derivative of 2x is technically just 2. Technically, remember, when you're doing implicit differentiation, you apply the chain rule to the extreme. So you multiply by the derivative of the inside function with respect to x. Okay, so that's going to be 2 times the derivative of the inside function with respect to x. That's the derivative of x with respect to x. We write that as dx. Okay, for the next part, the derivative of y is negative 1. Or you could think about you're going to multiply by the derivative of the inside function with respect to x. That's going to be dy dx. So it's going to be 1 dy dx, or you could just write it as dy dx. Okay, now here's the follow-up. Obviously, that's going to equal 2 minus dy dx. And you may be wondering, well, what do I do with that? But keep in mind, they told you what dy dx is. It's 2x minus y. So you can fill that in for dy dx here. It's going to be 2 minus 2x minus y, because that's what dy dx is equal to. And so in the end, d squared y dx squared is just going to be equal to, it'll be 2 minus 2x and then plus y. And again, they don't make you simplify. So if you leave it in that form, you're going to get the points. Just be careful. If you do simplify it, make sure you get all your signs right. Okay. Now, there's the second part here. It asks you to determine the concavity for all solution curves in the second quadrant and explain why. Well, remember that the second derivative tells you about the concavity. If the second derivative is positive, your graph is going to be concave up. If it's negative, it's going to be concave down. On the surface, I'm thinking, well, how can I handle all the points in the second quadrant? And then you think about it a little bit. Think about the second quadrant for a second. If you're in the second quadrant over here, all of your x's are going to be negative, right? Because you're going back a certain amount. All of your y's are going to be positive, okay? So I have no idea if that's useful or not, but come back here and look. If your x's are negative, -2 times a negative number is going to be something positive, okay? All of your y values are going to be positive. So I have 2 plus a positive value plus another positive value. We know that dy squared dx squared has to be positive. In quadrant 2. So the curve must be concave up in quadrant 2. All right, let's look at their answer here. They say, they take the derivative, we get a point for doing that. It would be up to 3 points, which gets us around a passing score, maybe just a little below. And then they explain that it's got to be concave up and y. And notice they just say x is less than 0 and y is less than 0, so 2 minus 2x plus y has to be greater than 0. Or you could say 2 minus 2x plus y is positive, okay? Notice they don't explain why it's positive, they just say it is. And so that's all you have to have there. So if you got all that, you got 4 points now. Let's go on to part C. Okay, part C says let f be the particular solution. They don't ask us to find it. They do tell us that it passes through the point 2, 3. And they ask if it has a relative minimum, relative maximum, both or neither at that particular point. Now, just to make a point here, normally when we're talking about relative minimums and relative maximums, we're looking at the place where the derivative is equal to 0, because that's where you've got a tangent line that possibly is horizontal. But remember, when you do that, it's possible that your function could be increasing level and then increase again, and that you have neither a relative minimum nor a relative maximum where the derivative is equal to 0. So remember, we always make the number line with the values where the derivative is equal to 0. We call those the critical values. And so let's say it's at like 1 and 5, just to make up something. We then test values in the derivative, and we see, for values less than 1, maybe the derivative is positive and it's increasing. And for values between 1 and 5, maybe test like 2, maybe it's negative. And then you can see you have a relative maximum, and you can go from there. There's a problem. This requires you to be able to substitute values on either side of x back into the derivative. And on the surface, you think, well, that's fine. But if you take a look back here, the derivative has an x and a y in it. We would literally have to figure out x and y values where the derivative would be 0. And we'd have 2 points we'd have to test. And how do you check a point that's higher or lower if you have an x and a y point? I don't think that's even very clear. Long story short, because this derivative has an x and a y, you're not going to be able to test points above and below the place where the derivative is 0. And it's going to be questionable as to whether or not you can even figure out where the derivative is 0. That's going to fail, okay? But come back here and look. They're looking at the point where x is equal to 2. So we do know that. And actually, we know the functional value is 3 there. So we know it's going through the point 2, 3. We just can't really test above or below. Okay? Well, if you think back, we had a second method for finding relative minimums and maximums. Remember, it was called the second derivative test. And the second derivative test only involved knowing the derivative at a particular point. You didn't have to check to the left or to the right. And this is a situation where you can't really check to the left or to the right. This is where the second derivative test comes into play. So remember what the second derivative test says. It says if you have a function and the derivative is 0, at that particular point. So f prime's got to be 0. If the second derivative is positive, that means your graph is concave up at that point, means you have a relative minimum, okay? If your graph has a derivative of 0 at that point, and the second derivative is negative, that means it's concave down, that means it has a relative maximum. And meanwhile, if f prime is not 0, then your function has a slope that's not leveling out, and it's neither a relative minimum nor a relative maximum, okay? Well, here's the great thing. They gave us a point, right? They gave us the point 2, 3, and we have the derivative equation. Let's put 2 in for x, and let's put 3 in for y, and check it out. 4 minus 3 is 1, okay? When x is equal to 2 and y is equal to 3, the derivative is equal to 1, which means we have neither a relative min or max. Okay? Let's take a look here. Here's part C. Here's their answer key. They check it. The slope is 1, has neither relative minimum nor relative maximum. Okay? If that derivative had been 0, then we could have substituted back into our second derivative equation there. And if it had been positive, it would have been concave up, and that means we would have had a relative minimum. If it was a negative second derivative, it would have been concave down, and it would be a relative maximum. Okay? This has been coming up a lot more. I think it'll come up somewhere on the homework as well. Okay? Now, part D. By the way, part D here is 3 points. So if you were up to this point, you would already have 6. You'd already be at a 5 pace. You could technically just stop, although you always want to try to get all the points because you don't know where you're going to need to make them up later. Okay, part D is weird, and most free responses will have a part that's kind of weird. It says, for all values, we want to find values of constants m and b for which y equals mx plus b is a solution to the differential equation. Okay, so our differential equation is dy dx equals 2x minus y, and they're telling us y equals mx plus b is a solution to that differential equation. Okay, notice they never ask you to separate variables and solve, because we can't. But if this is a solution, that means its derivative has to be equal to this thing over there. So that's a constant, right? If this was 3x, the derivative would be 3. If it was 5x, the derivative would be 5. If it was negative 2x, the derivative would be negative 2. Derivative is just going to be m. That's a constant. Derivative of a constant is 0. Okay? So the derivative of that function is m. It's just the slope of the straight line, right? M has to be equal to 2x minus y, okay? And we can actually solve that. That means y needs to be equal to 2x minus m. What are they asking me to find here? They're asking me to let me read the question again here to see what they were asking for exactly. We want values that make this a solution to the differential equation. Okay, so basically we should be able to substitute in the points 2 and 3, right? Because it's got to pass through the point 2, 3. And let's see what we get here. So when x is 2, y is supposed to be 3. So that's going to be 4 minus m is equal to 3. And let's see, I have made some kind of horrible mistake here. What have I done? Let's see, 2x minus y is equal to m. Oh, okay, let's back up. This happens sometimes. This is why I'm showing you a live question. All right, we actually know, they told us that y is equal to mx plus b. Okay, so I can actually substitute that in the equation. That's going to be 2x minus, in place of y, we've got the mx plus b, because y is equal to mx plus b, and that's got to work out to equal m. Okay, so we can solve this equation. Let's see what we've got here. All right, we've got 2x minus mx minus b is equal to m. Okay. I think I'm going to put the everything except for the let's see, I'm going to put the x term on the other side. So we've got 2x minus b is equal to mx plus m. Okay? Notice there's an x term here and there's an x term there. That means m has to be 2, right? So we have a 2x there if those two things are equal. So m would be 2, okay? And if I fill in 2 for m, that would be 2x plus 2. That means the constant here needs to be equal to 2. So a negative 2 would be equal to 2, and that would make b equal to negative 2. Okay, so that was kind of all over the place. Let's see how they write this out. And keep in mind, if you don't get these 3 points, you have a 6 out of 9 here, then you're at a 5 pace already. So you'll see here they say we can take the derivative here. The derivative is just m, and notice, by the way, you get a point just for saying that the derivative is m. So you would have 7 out of 9 just doing that. Okay. The next part here, they said the derivative was m. They set it equal to 2x minus y because that's the derivative. Okay. Notice you get another point just for setting those two things equal. So even if you didn't know how to finish the last part, you're up to 8 out of 9. Okay. And then finally, the last part here, you did have to kind of fiddle around. They got the whole equation equal to 0. Okay, so they said they grouped the x's together. They said 2 minus m times x. This is where they substituted in for the y. Y was mx plus b, and they just got the whole equation equal to 0 here. So the constants are grouped here, the x terms are grouped here. So to have the x terms cancel, m would have to be 2 to get 0x, and then if m was equal to 2, 2 plus b would have to be 0, so this whole thing equals 0, and that would make b negative 2. So they did it a little bit differently than I did. But again, even if that whole thing went over your head, you got an 8 out of 9. Just by finding the derivative and just noting that it's got to be the same thing as the other derivative. So keep that in mind on these questions. Sometimes they look like they're going to be terrible, and a lot of times even just writing down what you know will get you some points. Really important strategy as you go through these questions.